C and 2. C, it's going to be a tie. Got me 15. Neither. Okay. Now, it'd be nice if neither actually hits the table. I think that's going to miss the table. Well, apparently that one hit first.
I changed my opinion to B.
D?
B.
B?
Yeah, B. No, not really. I was thinking ball B hit first.
Okay. On that situation.
Yes.
All right. Place your bets. Apparently hitting the table was in the cards there. Swing that around. Thank you. For those who missed it, one of them hit the table. We're redoing it. I forgot to take coordination into account. All right, here we go. Make sure it's level. Now, did they hit exactly at the same time?
No.
Or close enough? Probably not exactly at the same time, but close enough to this. So congratulations to the majority. Were those five? Way to be brave. Why? Because the one that was shot that way was obviously going faster.
But it's got a further distance to fall.
And what's causing it to change its speed?
Gravity?
Air resistance.
Sure, we'll go with that. The nitpick is force due to gravity or weight. Would have been, I think, a better answer. However, in this context, you might be able to get away with gravity. As will be said probably many times, gravity is this huge, huge topic of which the force is one small aspect, acceleration is a small aspect, gravitational constant is a small aspect, the curvature of space and time because of it, another aspect. So which way is the weight pulling on the ball? Which way does the force of gravity pull on it? Yes. So horizontal and vertical are independent there in the fact that they are both being pulled downwards at basically the same net acceleration. So if I'm projecting a ball horizontally outwards, if I know my initial height, I know my initial speed, I guess also, and the direction, so I know my initial velocity, I can predict how far out it's going to go. So let's write down our big five characteristics, delta x. I'm going to use S right here. Hopefully that, if I can mess anyone up. VI, VF, A, and T. I have two different directions involved here, and so as in chapter 2, I would just leave that and I'd write numbers next to it. Now I'm going to write numbers on both sides of it because I have a horizontal side and I have a vertical side. Let's actually use numbers here. So let's say I take it from a height of, that was about 1.7 meters. I got this number, initial velocity, we'll just say 5 meters per second, 0 degrees. So I'm giving velocity in polar form. So what do we know? So horizontally, do we know any of this information?
And that initial velocity would be 0.
Horizontally?
For the initial, because it's not moving at all, so it would have a velocity as
Oh.
The hypotenuse.
So you're talking about before I hit the
yeah.
flip? All right. The trouble with that is that before I hit the switch, you're right, it's not moving. The thing projects it, so it accelerates, and then it falls under the spell of gravity. Yeah, I'm still going with that. The acceleration changes. So we can't use these equations if I'm starting there. Unless I break it, I have to give you a lot more information.
Okay.
So the initial velocity is here. This is assuming it has just been projected.
Okay.
Similarly, if I ask what's the final velocity, I'm not talking about when it hits the ground. I'm talking that moment just before it touches the ground. All right?
So if that's in polar form, wouldn't that be the hypotenuse 5? Or no?
Okay. Technically not a hypotenuse in this situation, but why is this not a hypotenuse?
That's just the word I know. I don't know.
Not a straight line.
Typically, yes, you're absolutely right. In this case right here, there's two cases where it's not a hypotenuse. This is one of them. Why? I heard another voice.
It's not a straight line.
We're talking about just the initial. We're not worried about the projection afterwards. I assume you're talking about breaking into components.
Yeah.
Yeah. All right. So let's break it into components. Perhaps it'll become clearer. So 0 degrees. How do I draw my triangle? Normally I would break it into horizontal and vertical components, but it's already horizontal. That's why it's not a hypotenuse.
Okay.
The other situation is if I shot it straight up, it'd be difficult to draw the triangle there.
Okay.
Unless I wanted to come up with a really funky and complicated coordinate system, which I don't want to do, and neither should you. So what is my initial velocity horizontally?
1.7. I mean, 5 meters per second.
Yeah, 5 meters per second. What about vertically?
What is that?
I was going for initial velocity. How fast is it going up? As soon as it's launched, how fast is it going up or down? If the thing is shot horizontally, there's no vertical piece to it. So it's 0 vertically. Don't worry, we'll get to one where it's at an angle. We'll have a non-zero value there. All right, so I got my initial velocity down. We have just established something by, actually, as soon as 5 meters per second was said, and I wrote that down, what did we just establish?
Initial velocity for both.
Sorry, say it again.
We know the initial velocity for both.
That's not, we do know the initial velocity for both, not what I was going for. Oh, well, let's keep going and we'll eventually come up. Or Jahir, were you raising your hand or just moving it?
Raising my hand.
Yes.
You know what position is positive?
Keep going on that. Say it again.
We established that positive is to the right.
Yes, that's what we just established. All right. So now, what else do we know?
The final velocity for horizontal, if there's no air resistance, it's still 5.
And we will let's go ahead and make that official. Okay. What else do we know?
The displacement. Displacement?
Is what?
1.7 meters.
I have horizontal and vertical displacements. Which one is that? All right, so 1.7? Is that what you're saying? Yes?
Would you put the negative sign in front of it and it's falling down?
You want the negative sign in front of it? Does it matter? All right. So basically, if we leave it like this, what have we just established? Yeah. If you put the negative there, you're saying up is positive. So which is better? Whichever way your mind is working at that moment. Since he started out with 1.7, let's stick with that. And when we get, there's another piece that becomes critical about what sign to use. So when we get there, I'll talk about if we had made up positive, where else it would have changed. All right, so we're establishing those are the positive directions. If you want I hat, J hat, go for it. This would be I hat, J hat. All right, we know two other pieces of information.
Vertical acceleration, 9.8.
Give me the whole thing.
9.789.
Not what I was going for.
Oh, acceleration due to gravity is 9.8 meters per second.
How'd you get there?
Squared.
There we go. All right. I was looking for units.
Oh.
We are assuming we're near the Earth.
And horizontal acceleration is 0 meters per second squared.
Yeah. So typically in a projectile motion problem, what you're going to start out with, the things that you know are horizontally, because we're not throwing air resistance into it unless you really are electrical punishment. 0 meters per second squared is the horizontal acceleration, and vertical acceleration is whatever the acceleration of gravity is where you are. So right now we're assuming Earth. I've on task put it on Mars, Venus, the Moon. So just if you see something other than Earth in the description of the problem, you might want to look at the first page of a test where I would give you those values. Or if I don't, ask. All right, now, Gina. Back to what Gina was saying earlier about the plus and minus. If we had chosen up to be positive, that would be negative 1.7, as you were suggesting, meters, and this becomes negative also. Probably the biggest mistake I see is making that negative and this positive or vice versa. Now there are situations, if I shoot it up to a higher level, then there'll be opposite signs, but if it falls, they'll be the same sign. Now, presumably I've mentioned in a video at least, if I know 3 things, I can find the rest of it. I know 3 things here. I know 3 things here. Technically, this 5 meters per second comes from the fact that the initial was 5, and that's 0. So this is technically something we calculated. We only know 2 things initially, horizontally. But there is one thing that binds them both, and it's not the ring.
Can you explain why acceleration is 0?
Acceleration is dependent upon force. The only force acting on it once it's launched is the force of gravity downwards.
Okay.
So there's only vertical acceleration.
Okay. So then, oh, but the initial, okay, I got what you're saying.
The one thing that is going to always be common for both of them, and I didn't thought through, you know, it's one of those moments where I'm going, all right, in quantum physics, can I come up with an exception? I have not yet.
So because there's no air resistance, it's zero.
Yes.
Okay.
If there were air resistance, then acceleration now is a function depending on how fast it's going. And that's a calculus-based problem. Or potentially an unsolvable problem, depending on how complicated you want to make that. Maybe I don't get this right. It's only been 2 years. I should be able to figure out how not to bug up my glasses. Okay. So I need to find time. Time is the glue that binds these two together. And so and the vertical determines how long it's in the air. So which of these equations would I use to find time given this information?
Top one.
Okay? Why the third one?
Because we have our initial velocity, and we also have acceleration.
Good. I don't have final velocity, and so I need the equation without final velocity. All right, so I've got 1.7 is equal to 0 times time plus 1/2 9.8 times squared. 1.7 is equal to 4.9 times squared. I hope when they replace that board, they put it up a foot higher. That would just really be convenient for me. So T is the square root of 1.7 over 4.9. Actually, I'm going to do the math thing first. 4. Mathematically, we get to this point, so there are actually two solutions. What's the other solution? Yes. We're beholden to the math, but there are times when we look at the math and we go, well, that's just not going to happen. If I shoot an object at time 0, it will hit the ground in some time in the future. So mathematically, this is a solution for it, but it is, we can throw it out based upon reality. All right, so would someone be kind enough to actually tell me what this number is? About 0.5 something? 0.59. 0.59? Keep going.
Seconds.
Yes. And thank you for interpreting that as I wanted units as opposed to the next decimal. All right, so 0.59 seconds. Once I have that, and no, it's true for both horizontal and vertical motion, now I have enough information to figure out how far it goes horizontally. I guess I never actually stated that's the problem, but we're trying to find how far out it goes. So what equation would I use now? Which one?
What, would you do the same one there?
Sure, why not? So we end up with, the fourth one would also work. So we have R is equal to 5 times 0.59 plus 1/2 0t squared. At some point, the 0 terms, I mean, that's 0. It's just going to drop out. At some point, I'm just not going to write them. 195. I think. That sounds about right. And so what we have is the simplest of the projectile motion problems. But I know that's not good enough for you. You want more complicated. So let's make it more complicated. Questions before we make it more complicated? All right, let's make it more complicated. We'll leave that up there. I'm assuming this has been written down by those who were writing it down.
So, why did the resultant go in the horizontal for displacement? The horizontal?
Ultimately, that's what I wanted to find, is how far out it went.
Okay.
I didn't state that initially, but if you had read my mind, you would have,
Okay.
you would have known. Sometimes I just do explorations of what's happening here, and sometimes I actually state a problem. On a test, I would actually state the problem as opposed to, here's the situation, just explore, have fun. I'm now thinking of a test question where I could get away with that.
So it's impossible to find the displacement for horizontally, or it's just the, like, why would you not put 2.95 meters for displacement? And
This.
Okay.
Yeah, I
Okay.
just, once we had the answer, I thought, I don't feel it.
Oh,
It's written
okay.
down here. Was that what you were going for, Dylan?
No.
No, okay.
When you wrote t squared, did you mean to do that, or just put 0.59 there? I mean, there's 0.59 is supposed to go there, right?
Yeah, 0.59 would
Okay.
go there, but you're multiplying times 0, so
So it's okay.
it's gotta be 0. I was feeling lazy and didn't feel like writing it.
That's okay. Just making sure that there wasn't any variables that we didn't cancel out and get rid of.
Yeah, so.
Plus 1 there, 0.
Thank you.
All right.